If we consider dilations, there's two types of dilations. Dilations from the x-axis, and you can see there, so from the x-axis or parallel to the y-axis. And that typically means we're stretching the points up from the x. So from the x-axis means that each of those points get a little bit increased by a factor. So in reality, our graph gets skinnier. Okay. From the y-axis means we tend to stretch these values out here, and our graph stretches from the y-axis. So it gets wider. So if we think about which value is getting affected here, this green line here, the x value increases. Yeah. So from the y-axis affects the x value, and from the x-axis, where they're getting bigger, my y value increases. So from the x-axis, it's the y value increases. And you can see that over here in our formal notes. The curve with the equation y equals f of x, a dilation of a units from the x-axis means the y value gets multiplied by a factor of a. Okay, and we'll highlight what that means there. If we dilate from the y-axis by a factor of a, it means my x value gets affected. So if we use a similar process to what we used last example, if, as the example was there, we dilate by a factor of a, so from the x-axis, so from the x-axis, I've got the point x dash y dash will become, from the x-axis, we're stretching up, so it becomes the point x ay. So the y value increases. So if I rearrange that, x dash doesn't change, the new x value hasn't changed, the new y value is equal to a times the old y value. So if we rearrange that, the new x is the same as the old x, and actually we'll probably change that notation. The old y is equal to the new y on a. So these are the two key statements here. So if y is equal to sum f of x, the new y value, y dash on a, is equal to f of x dash. So I get a rule that says the new y value is a times f of x. So the key is, from the x-axis, the multiplication factor is out the front of the function. All right. If we compare that to dilating from the y-axis, so if we move from the y-axis, we're shifting across, we're stretching that way. The x value gets affected. So that means my point xy becomes, or x dash y dash, becomes the point, the x value gets increased, the y value doesn't change. So if I go through the same process, x dashed is equal to some ax, y dashed is just equal to y, rearrange it, x dashed on a is equal to x, y is equal to some y dashed, and if my function is y equals f of x, well, my new function is just y dashed is equal to f of the old x value is x dashed on a. So this is the really tricky one. Look where that a is there. So f of x on a is a dilation by a factor of a from the y-axis. Okay, so that's a really tricky one to try and consider. So let's have a look at this example here. Determine the rule for the image. So we want to know the rule from the image. The graph of y equals x squared is dilated by a factor of 4. First up from the x-axis. So if we dilate from the x-axis, that means the point xy becomes, now from the x-axis means we're going out this way, or sorry, my mistake, from the x-axis we're shifting up. So that becomes the point x 4y. The y value gets multiplied by a factor of 4. So my new x value is just the old x value. The new y value is simply equal to 4y. Transpose slightly, x is simply just x dashed, y is equal to y dashed on 4. My new equation, let's just change the colour slightly. My new equation, we get y, which is y dashed on 4, is equal to 1 on x squared, which is just x squared. So my new equation, y is equal to 4 over x squared. So that's a dilation by a factor of 4 from the x-axis. Okay, how does it look if we work from the y-axis? My new x value and my new y value is equal to, well, from the y-axis, I'm stretching that way, so the x value gets affected, so it's 4 times bigger. Y doesn't change. X dashed is equal to 4x. Y dashed is equal to y, which means x dashed on 4 is equal to x, and y dashed is still y. So substituting into the equation that we've been given, which is y equals 1 on x squared. So if y equals 1 on x squared, y is simply y dash, so that's fine. And 1 on x squared, well, x is equal to x dashed on 4, which is actually equal to, which implies y is equal to 1 on x squared on 16, which we could write as, okay, so there's my new function. And that's where our dilations can be a little bit tricky, okay. We could leave it in that form. So that y equals 16 on x squared, it doesn't look that dissimilar to that one there. If y equals 4 on x squared was a dilation by a factor of 4 from the x-axis, well, y equals 16 on x squared happens to be a dilation by a factor of 16 from the x-axis, but it is also a dilation from the y-axis by a factor of 4. So our dilations we've got to be really careful about. So the key points, A at the front, let's get a colour in there. The A at the front, that's from the x-axis, okay? So the y value is increasing, and the function x on b, that's by a factor of b from the y-axis. So it's got to be really careful about those dilations.